Hi guys, today we're going to be talking about reference angles and how they apply to trigonometry. So before we get started, I would like you to complete this warm-up. So if you could pause this video, complete the warm-up on a separate sheet of paper, and then unpause the video to double check your answers, that would be wonderful. You can pause now. Alright, now that you've completed the warm-up, you can go ahead and double check your answers. A couple of things I want to point out with this. The second two problems where we are given radians and we need to graph the angle in radians, I would highly recommend writing down your 0, pi over 2, pi, 3 pi over 2 spots just to kind of see where those are, and then we can always find a common denominator between the angle we're writing and those kind of staple points around the origin that we want to graph. So that can kind of help you figure out where those angles are going to be located. As for the last two equations, the last two problems, we need to add or subtract 360 degrees when we're working in degrees, or add and subtract 2 pi when we're working in radians to figure out different coterminal angles. And keep in mind, you might have to add multiple times or subtract multiple times in order to get the positive or the negative. Now we will begin discussing what a reference angle is. So, the values of a trig function of angles greater than 90 degrees can be found using a corresponding acute angle called a reference angle. The reference angle is the acute angle theta prime formed by the terminal side of the theta and the x-axis. So what this means, if we go ahead and look at our first example here, we see we have this red line that is theta. So that is our angle that we know, which means this blue line is going to be known as our reference angle. We can use reference angles when we potentially know the reference angle and not the actual angle that is over 90 degrees. So for example, in this first one, if we were to say our reference angle was 40 degrees and we want to calculate our angle theta, we could take 180 degrees and subtract 40 degrees to get a total of 140 degrees for our angle theta. We need to take 180 degrees and subtract off the 40 because if we took an angle from our initial side and flipped it all the way over, we'd have 180 degrees. And ideally, that's what we're trying to do, is we're trying to break up this 180 degrees into two parts. We know one part is 40, so we need to calculate for our remainder, which is going to be 140 degrees. In our second example, we'll look at the one to the very far right. We have a very large theta value, and our theta prime is going to be from the terminal side, so that is this line that I'm going over, and it's the closest direction to the x-axis, whether it's the positive side of the x-axis or the negative side of the x-axis. Our reference angle is always going to be positive, something to keep in mind here. So, once again, for example, if we said that this reference angle was, let's go with 30 degrees, and we want to figure out what theta is, because theta is coming all around to the fourth quadrant, we can compare that to 360 degrees, where we have to just subtract away 30. So we could take 360 degrees, subtract off 30 degrees, and we are left with 330 degrees to represent our angle theta. There we go. All right, and finally our last example is if we have an angle that pushes into the third quadrant. So we know from the initial side, halfway is going to represent 180 degrees. And since our reference angle is based off of the terminal side, and it's the acute angle to the x-axis, we need to figure out 180 plus whatever our reference angle is going to be our total value theta. So once again, for example, if I said my theta was 140 degrees. In order to find my original theta, I need to take 180 degrees plus 40 degrees to get a total of 220 degrees. So now that we see how reference angles can be used, we want to be able to calculate them. So, for example, we want to find if theta equals 320 degrees, we would like to find the reference angle, or theta prime. This example follows along with number 2 in your notes. So, we know that our angle theta is 320 degrees, which we can look at as almost making up a full circle of 360 degrees. Because our reference angle is that angle based off of our terminal line to the nearest x-axis, we can figure out what that theta prime value is, what our reference value is, by taking 360 degrees, what makes up a full circle, and subtracting off the part that we know. So subtracting off 320, which leaves us with a final 40 degrees for our reference angle. In problem B, this is slightly different because we were given a negative angle value. We could graph this negative angle value, but it can sometimes be very difficult to figure out the reference angle because the reference angle is always positive. So an easy way to approach this problem is to take your reference angle and find a positive coterminal. So this problem has already done it for you, but we could find a positive coterminal by adding 2 pi. And therefore we get 7 pi over 6 as our positive coterminal. So once again, we know this makes half of a rotation around, which in radians represents pi. Now we're trying to figure out what that remainder of the rotation is that will represent our reference angle. We know the whole thing in red, which I will delete the blue, so we know the whole thing in red, including this piece, is 7 pi over 6. So to find just the part that I've circled here, we can take 7 pi over 6 and subtract off our pi value. Now just remember, when we're subtracting fractions, we need to get a common denominator. So really, we're looking at 7 pi over 6 minus 6 pi over 6. And that will give us a total of pi over 6, which will represent our theta prime, or our reference angle. Now I would like you to try problem 3 on your worksheet by yourself. Pause the video here and resume once you think you have found the reference angle for each theta equals 140 degrees and theta equals negative 3 pi over 4 radians. Once you think you found the answer, resume the video and find out if your answer is correct. Go ahead and double check your answers now. One thing to notice with A is that we have 140 degrees. We haven't quite made it yet to 180 degrees. So to find that reference angle, we can take 180 minus 140 and get a total of 40 degrees. For B, once again, since we have a negative radian, we can add 2 pi to that to find the positive coterminal. So we can graph that, so our reference angle will remain positive. Once we graph our positive coterminal, the shortest way to get from the terminal side to an x-axis is by kind of doubling backwards. And since that value is over 180 degrees, which is pi in radians, we can take our 5 pi over 4, subtract pi, which is equivalent to 4 pi over 4, and get our reference angle to be pi over 4. Now that you have completed all your notes, please grab a blue worksheet to go over reference angles. Once you have completed the blue worksheet, you can grab a quiz review worksheet. All of the questions on the quiz review worksheet will be similar to the questions on the quiz next class. Good luck studying!